Chapter 5, gases. Are we doing that again? What? Okay, I don't know. This computer, I think, is possessed. Okay, that's the first slide, right? Yes. Wow. Okay. Breathing. Everybody breathing? It's good. You ever think about how breathing works? I mean, we just do it all the time without even thinking about it. How does that work? It actually has to do with differences in air pressure, the pressure of a gas. So you move about 8,500 liters of air in and out of your lungs every day without even thinking about it. Breathing is possible because your body can create pressure differences between the gas in your lungs and the gas outside, the air. So your diaphragm expands, your lungs expand, the volume increases, the pressure decreases, and that causes the air to flow into your lungs. And then when you exhale, your diaphragm comes up, compresses your lungs, the volume goes down, the pressure increases, and the gas comes out. And repeat, right? So pressure differences in gases are really, really important. So what is pressure? Well, pressure is defined as the force exerted per unit area. So force divided by the unit of area. Gas molecules are very tiny, but they do run into things, and so they do strike surfaces and each other with a certain amount of force over a very tiny area, and so the pressure does end up being significant because there's so many of them. It's a little bit like being pecked to death by a duck, right? So a duck pecks you, right? It's like, anybody been pecked by a duck? It hurts, but it's not going to kill you, right? It's like an annoyance. Okay, so let's leave the duck out of it. Let's think about a fly. Fly in your room, you're trying to study, the fly keeps landing on your arm. Does it hurt? No. You just brush it away, and it keeps coming back over and over and over again. You've all experienced this, right? And after a while, you're just ready to blow up the whole house to get rid of this fly, right? It's just a lot of little over and over and over again. And that's what the expression being pecked to death by a duck means. And there have been periods in my life where I was seriously, this is one of them, I was being pecked to death by a duck, like the child peeing in the Beyblade Stadium. It's just, there's another duck peck. It's just over and over, and they just add up until, you just have to take some deep breaths and go on. Okay, so let's get back on track here. Gas pressure. The pressure of a gas is going to depend on several factors. First of all, the number of gas particles. The more gas particles, the more they're going to hit the surface, and so you're going to get pressure. And the volume also matters. So if you have a lot of gas molecules in a small volume, you have a high concentration of gas molecules, you're going to have higher pressure than if you had the same number of gas particles in a large volume. Okay, because they're not going to hit the container as frequently, they've got more space. So the volume of the container is going to be a factor, and then also the average speed of the gas particles. So we've talked about temperature. Temperature is the average kinetic energy of matter. So we think of kinetic energy as the energy of motion, things flying through the air. You throw a baseball, and yes, it has kinetic energy. But if the baseball is just sitting on the bench, it still has some kinetic energy. The molecules in the baseball are moving, they're wiggling, just like you guys are all just, moving a little bit in your chairs. They're not moving relative to each other, but they're moving, and so that's kinetic energy. You increase the temperature, you increase the kinetic energy. It's like everybody getting agitated, and wiggling around more. You're getting fidgety. That's why I gave you a break, so that you could, get it out. You increase the temperature of the gas, you increase its kinetic energy. So the gas particles are moving, and when they're moving faster, they're going to hit harder, and so that's going to increase the pressure. So you inhale, volume of your lungs increases. Volume of the container of a gas affects the pressure. You increase the volume, pressure decreases. lower pressure, then the gas outside, the external air, comes in. The air pressure outside, we call it the atmospheric pressure, relatively constant. And so the air goes in, the air goes out. Any questions about breathing?